Yes, so tell me, you are a network engineer in a company, right? And guys, there are two types of network. Okay, there are, let's suppose, network in two building. In a company, there are two building. In both company, you have some end devices, means client. Let's suppose in building one, you have some switches, access layer switches. Let's say switch one, or let me design this better. I have some switches, guys. Switch one, switch two, switch three. Right? Let's suppose there are three floor. At each floor, I have one switch. In building two also, you have three floor. Right? Now at each floor we have 100 number of user. How many users are connected with this switch? 100 users. Yeah, yeah. 100 number of users are there at each floor. Right? Let's suppose these are different department. This is your switch one, switch two, switch two, and switch three. In this building also, I have, let's say, switch 4, switch 5, and switch 6. Try to understand the concern. Right? Here also, how many users I have? 100 users. 100 users. And 100 users at each floor. So how many users are there, guys, in building 1? In building 1, how many total number of users are there? 300 users are there. In the same way, in building 2 also we have 300 number of users. Now let's suppose in building 1, all users are in single broadcast domain, right? What I am saying, in building 1, all client machines are connected with this switch, switch 1. On switch number 2 also, all 100 users are connected with switch number 2. Here also, on switch 3, all 100 number of users are connected with switch number 3. But in building 2, we have multiple broadcast domain. Multiple broadcast domain means how I can create multiple broadcast domain here in building 2. As per your knowledge, whatever things I have discussed till now, on the basis of that, what option you have? No, we didn't discuss VLAN till now. I can connect these all switches with the help of router, because router has purport broadcast domain, right? So if I will place one router over here, then what will happen? Now all three switches are in different broadcast domain. Here devices are connected like this. Okay, here these all switches are connected like this. Maybe I have multiple links between switches for redundancy, right? Like this. These all switches are connected with and devices. Again, these all switches are connected with and devices. Now tell me how many total number of MAC addresses will be there in the MAC address table of switch 1. Switch 1 is going to install how many MAC address? 300, because 300 number of users are there. All are in same broadcast domain, correct guys? So all switches will have 300 MAC addresses in their MAC address table, correct? And here also. Now tell me, according to you, which network is best? Which network is good? Definitely in building 1, because no, building 1, brother, here I don't have router. I don't have router. Router cost is, let's suppose, 1 lakh rupees. So you are saving 1 lakh rupees in building 1, right? Yes, for the management purpose, building 2 is the good. Because see how many MAC addresses switch 4 is going to carry, is going to install in their MAC address table. Only 100. Switch 5 also 100, and this switch also 100 number of MAC addresses. So it will be easy to check MAC address table here. It will be easy to find end client machine here. It will be difficult to check MAC address table in building 1, because each switch has 1000 number of MAC addresses in their table. So let's suppose if I want to find a client, right, that this client is connected on which port or on which switch, it is going to be complicated as compared to building 2. The second issue guys, see the performance over here. If these switches are connected with one router, so that these LAN users can access internet, so there is one router, and let's suppose switch 3 is connected with my router, and this router is connected with the internet. Maybe both building are connected together, and then both building routers are connected with internet. Let's say different internet. Here also I have one internet, and here also I have one internet, and both internet are connected together, so there is no connectivity between both building or between both branch. Like this also I can connect, or I can connect these devices together as well for internal routing, right? For internal routing I can connect like this, and I have one ISP in building 1, one ISP is connected with building 2. Now either I can perform load balancing between ISPs. You already know the benefit of 2 ISP. Either I can achieve load balancing, I can configure what active standby scenario means, primary, secondary, one for backup, one for use. So that's why here I have 2 ISP. Ignore it for now, don't worry about that, we will discuss later. Now try to understand layer 2 network, router 2. Now guys, if any client machine, let's say, want to access internet, this machine want to access internet, so it will ping to 8.8.8. Source IP will be IP address of PC. Destination IP, let's say 8.8.8. Source MAC address of PC. Destination MAC, default gateway. This PC is going to check their ARP table. Let's suppose in their ARP table entry is not available. Then this machine is going to generate ARP request message. ARP is broadcast message, right? ARP is a broadcast message. So this switch is going to forward it to all 100 users here, and to switch number 2 also. Switch 2 is also going to send broadcast packet to all 100 computer, then it will send to switch number 1. Switch 1 is also going to send 100 number of broadcast message from their interfaces, and it will send one copy to default gateway also. Now which device will generate reply? Which device will generate ARP reply? Your default gateway. Why? Because when default gateway will receive it, it will check first destination. So destination is broadcast. Router can receive traffic in 2 cases. If destination is broadcast, or if destination is the MAC address of router, right? In two scenario only router is going to accept it. Otherwise, if destination is anything else, it will discard it. Now destination MAC is broadcast, so it will accept and it will check type field. In the type field value is type code of R protocol. It will hand over to R protocol, right? And R protocol is going to generate ARP reply. That is fine. But what about rest 299 computers, guys? What about these switches? See, these switches has flood the packet, right? It have sent multiple packets from their interfaces. Definitely these devices are using their CPU utilization. And when a client machine, let's suppose this client machine, when this client machine will receive that broadcast message at layer 2, it will open, it will check destination MAC. Oh, destination MAC is broadcast, so it can be for me also. Let me check layer 3 information. So at layer 2, this machine is going to decapsulate the frame, then it will hand over actual rest data to our protocol, correct? And our protocol is going to drop it, because target IP address in the ARP will be the IP address of default gateway. So each machine, not only this machine, like this machine, all machine, rest 299 machines are performing encapsulation at layer 2, performing decapsulation at layer, layer 2 ARP 2 times. That means this machine is processing the ARP packet, ARP message, ARP request. After that, it is dropping it. That means it is using their CPU utilization, right? First issue is complicated to manage. Second issue is we have high CPU utilization, because whenever any machine will generate broadcast message, switch is going to flood it to all devices, because all devices are in single broadcast domain. Second issue. Here, if this machine is going to resolve MAC address of their default gateway, right, it will forward ARP request to switch number 4. Switch 4 is going to forward it to all 99 computers. It will not forward to switch number 5. It will forward to router. Router is going to generate reply. Even this broadcast message is not for router, then also router is going to drop it. It will not forward from this interface or from this interface. Second issue in this network. Benefit is low cost, but now I have one router here as well. More cable. Like here, if you will connect these switches also, then see, here we have more cable in building 2. Don't worry about that. That is not major change. Guys, third problem. Try to understand. This router knows these all 100 users or all these 3 departments with the help of single network ID, correct? That can be, let's say, 10.1.1.0/24. All users, or not this, 10.1.1.0.0/24, because I have 300 users. Let's suppose this is my /23, right? For 300 user, I perform subnetting. So router knows these all 300 or all these 3 departments with the help of single subnet. You know the issue. Let's suppose this department means third floor, which is connected with switch 3. So employees over here are critical employees, right? In this department. Let's suppose I want to configure quality of service for this department. Like I want to give priority to this network, to these users. I don't have any option. I cannot configure on router, because router don't know this particular network. Router know entire network in the building 1, correct? But in this scenario here, I will have different subnet. Here I will have different subnet. Here I will have different subnet, right? So router knows each department with the help of their network ID. Each department have their own network ID, so I can configure quality of service. In the same way, if I want to configure more security for a particular department, here I cannot configure, but here I can configure. This is what benefit of segmentation, dividing large broadcast domain into a smaller broadcast domain. And guys, to divide large broadcast domain into a small broadcast domain over here, you don't need to purchase router. You have a tool called VLAN. See which type of network it is. It is local area network, correct? Local area network. Implementing network in building is LAN. Implementing network in building is called LAN, and VLAN stands for virtual LAN. Virtual LAN means over this physical LAN I can create multiple virtual LAN with the help of VLAN. Why we come up with VLAN? To segment the network, to divide large broadcast domain into a smaller part. Guys, in simple word you can say VLAN is a tool which is used to divide large broadcast domain or broadcast domain, one broadcast domain into multiple broadcast domain, right? So for the segmentation, VLAN is very important in real time. Why we are using VLAN? To segment the network, to divide large network into a smaller part. Like in a building, if I have 5 departments, so I will separate each department with the help of VLAN, and I will use different subnet. I will perform subnetting on the main network, then I will divide it according to our requirement with the help of subnetting. You already know subnetting. So guys, if I want to divide this network, let's say 10.1.0.0/16 is my main network. If I want to divide it into 3 parts, and in each network I need 100 number of IP addresses, can you perform subnetting? Yes. How many network ID will be there? 3. So router is going to store how many entry? 3. So can I configure security? Yes. Can I configure quality of service? Yes. Is broadcast domain still large? No. Switch is going to maintain how many MAC address table? 3. Now you can see MAC address table is also divided, guys. Now switch will have 3 number of MAC address. Let's say if you want to check MAC address table for department 1, for this department, you can check, brother. You can check. But earlier you can only run command show MAC address table because all machines are in same broadcast domain. So benefit of segmentation is, always keep in mind, benefit of segmentation is means dividing large network into a smaller network is improved performance, better security, and admin control. Now what is VLAN? How VLAN work? So guys, see what will happen. By default this is my switch, and by default VLAN is already exist on switch. By default VLAN is already there. Some VLANs are already there on your switch. That is in operating system. Again, if you will purchase one brand new switch from the market, and when you will access it, you will see there are already some VLANs, right? And most important VLAN that is by default exist on switch is VLAN 1. VLAN 1. And by default all ports of switches are member of that VLAN. This is why all ports belongs to same broadcast domain. But what you can do, you can put these 2 port in different VLAN and these 2 port in different VLAN. Now how many VLAN are there? 2 number of VLANs are there. Earlier how many VLAN was there? 1. Now switch is going to maintain how many MAC address table? 2. Right? And then I can assign these 2 ports in, let's say, VLAN 10 and these 2 port in VLAN 20. Now VLAN 10 user cannot communicate with each other. Now this PC cannot communicate with this PC or this PC. These 2 PC can communicate with each other and these 2 PCs can communicate with each other. So later we will see how we will make communication between two different VLAN, right? Because again we need routing. So we'll make communication possible between these two VLAN, don't worry. Now focus on dividing. How I am dividing it. How I am dividing large broadcast domain into a smaller part. Okay, so here you can read about VLAN, or let me do one thing. Let me open another file. CCNP switch. MAC address table, packet flow, CDP, LLDP, VLAN. Virtual local area network. It is used to break one broadcast domain at layer 2. Logically divided one broadcast domain into multiple broadcast domains. Logically. It means one VLAN defined one broadcast domain. So if you have 10 number of VLAN on switch, that means there are 10 number of broadcasts. By default, there is only one broadcast. And all ports are member of VLAN 1. This is part of virtualization. Virtualization is also in your syllabus, right? In CCNA 200301 also, and in CCNP also. So VLAN is also virtualization part, because I am dividing physical network virtually. Correct, guys? Now VLAN ID. It is 12 bits value represented in decimal. 12 bits values. So what can be range? What can be range of VLAN? If it is 12 bits, then what will be range? 0 to 2 power 12. 2 power 12, right? So 2 power 12 is, yes, 4096. So this is your range of VLAN. All VLAN will lie between this range only. From this range, guys, for now just keep in mind that one VLAN already exists on switch, that is VLAN 1, and VLAN 0 is reserved. We are not going to use VLAN 0. So we'll start using VLAN from VLAN ID 2. Okay. Zero, and this one is reserved. Then we have two types of VLAN: normal VLAN and standard VLAN. Used in enterprise network range. We will discuss about these things later, don't worry. Default VLAN is VLAN 1, and we have some again unused VLAN. You can see VLAN 1002 reserved for FDDI. These are, guys, other technology, like you can see token ring. These are other technology, and we have some reserve VLAN for this technology: 1002, 1003, 1004, 1005. These are reserved, and default VLAN is VLAN 1. One VLAN means one broadcast domain. All VLAN database is stored in flash memory. Generally, router and switches store their running configuration in RAM, in the running configuration. But guys, switch is going to store VLAN information in flash memory. Like if you have one switch, let's say in packet tracer, let me open packet tracer also. So it is stored in VLAN.dat. So if you want to delete the VLAN, you need to delete from this file. File name is VLAN.dat in the flash memory. So you will check flash memory of switch like this. You can see I can access this switch. It's booting. Booting means By default configuration register value is 0x2102. So guys, it will load iOS from flash memory to RAM, and then it will load NVRAM data, means saved configuration. Always keep in mind those all. So flash, in the flash we have only what? iOS. This is my operating system, main iOS image, right? Why we don't have any VLAN file here? VLAN 10. So are you able to see VLAN file, VLAN.dat file? Yes. So by default, switch not maintain any VLAN database. Even there is one VLAN, few VLANs are there by default, then also it is not maintaining any database. But whenever you will create VLAN on switch, it will start maintaining database, right? And it is going to store all information in flash memory. And command to check VLAN is show VLAN brief. You can see default VLAN is VLAN 1. Name is default, status active, and see all ports are member of this VLAN. Then I have one VLAN, more VLAN I have created, this VLAN 10, right? And this is name, and status is active. Then there are some reserved VLAN on the switches. Okay, so now I am going to design one network. What I will do, then guys, VLAN states, it is active, default state, data forwarding can done for that VLAN. So state should be active. Right now you can see VLAN state is active. So while troubleshooting, you will check VLAN state first. If you are troubleshooting VLAN issues on switch, first of all you will check the status. Status is active or shut down or suspend. It can be suspend, it can be shut down, or it can be active. By default, active. And from the active interface only you can forward data. From the active interface only you can forward data. Then guys, shut down. We'll stop data forwarding for that VLAN, for a VLAN on local switch. And suspended means we'll stop communication for that VLAN on all switches. Active means switch can forward data from that port. Shutdown means switch will not forward data from that port on local switch only, not on the neighboring switch also. But in the suspend, communication is going to be done for all, for that VLAN or all switches. Like I have 3 switch 1, switch 2, and switch 3. Correct? Here I have one VLAN, few users are there in VLAN 10. Here also I have few users in VLAN 10. Here also I have few users in VLAN 10. Say they should communicate. They should communicate. But let's suppose they are not communicating. So you are going to troubleshoot it. First of all, you will run command. So VLAN brief. If a status is shut down, that means these two users are not able to communicate with each other, right? Because it will impact on local switch only. It will impact on local switch only. But if a status is suspend, then these two ports are not accepting data on all switches. It will stop communication for that VLAN on all switches. Right? So we have 3 states here. Generally we used for troubleshooting. And I have one more state that is active, and we will see guys how I can put one interface in suspended, what can be the issue because of this, then shut down, and then I have one inactive also. So what it's saying, see, let's suppose on my switch, where is the topology? Yes, on my switch there is one PC, because this is important. Most of the time we are troubleshooting this issue in real time, right? And let's suppose this user is in VLAN 10. So what I am going to do here, go to config T and then interface F0/1 and say switch port access VLAN 10. This is how we put our interface in VLAN. Okay, now if you will run command show VLAN, you can see 0/1 port. Which command? Switch port access VLAN 10. Where is the port? 0/1. All ports are member of VLAN 1. And F0/1 is not showing. So we'll see this type of troubleshooting on switches. And sometime you will see a status is inactive. Inactive means what? A port is assigned to a VLAN, but VLAN is not in the VLAN database. Interface G0/2 switch port access VLAN 10. Do show VLAN brief. This port is part of VLAN 10, but if I will remove VLAN 10 from the VLAN database, so VLAN, no VLAN 10, I have removed the VLAN, so VLAN brief. Not showing. VLAN 10 is not showing. So interface F0/1 switch port. We'll do this lab by the way in EVNG for better output. This all you need to learn in switching. Somewhere it will show you VLAN is inactive. That means a port is a part of one VLAN, but that VLAN not exist on switch. So in that scenario, when a status is inactive, that means you need to create that VLAN. You need to add that VLAN in VLAN database. Any port assigned to a VLAN, but that VLAN is not available in VLAN database. This is the command to check. How to create VLAN? So command is very simple. Type the VLAN and then VLAN ID, what VLAN you want to create, and then like this you can configure name. But question is, why we will create VLAN? Why will we create VLAN, guys? Why we will create VLAN? For the segmentation, right? You know the benefit of segmentation. In real-time environment, VLAN are used to segment network traffic based on different criteria, such as traffic type. As I told you, I have the 3 departments. That means I have 3 departments. So for each department, if I have different subnet, then I can implement security, quality of service, or division wise. Here are some common types of VLAN and the types of the traffic or the department they typically represent. Data VLAN. Guys, see, these are what types of, you can say, department, right? Types of traffic, you can say, types of traffic, like data traffic, data VLAN, generally general data traffic, like two people are communicating with each other in a VLAN, right? Not on the call. Let's say they are sending file or they are accessing server. In that scenario, you are going to configure data VLAN. And if your switch port is connected with IP phone, then you are going to configure voice VLAN. Like let's say in this scenario, here this switch is not working fine. Let me use any other. It will be better if we will create lab in EVE-NG, because on the, guys, see, in the packet tracer I have less command, very less command, but let me try to configure it. And then I have one IP phone here, IP phone, one IP phone here, one IP phone here. That means switch port is connected with not two devices, right? Sorry, not like this. We can connect it like this. First IP phone and then PC. IP phone is connected with switch. The cable can't be connected to that port. Which type of cable it is? Which type of cable I will use? No, crossover cable, straight through cable, rollover cable. Which type of cable? Not able to connect. Let me check port over here. We don't have any module as well. But let's suppose this port is connected with two devices, IP phone and PC. That means you need to configure this port for data VLAN also and for voice VLAN also, because by default a port can carry data traffic only, not voice traffic. By default this port is a part of data VLAN only. So interface F0/2, I can say switch port access VLAN 10. So with the help of this command I am putting this interface in VLAN 10. For which type of traffic? For data VLAN, right? Now I will say switch port voice VLAN, right? So voice VLAN is also 10, or it can be 20. Let's say voice VLAN is 20. So I can configure one port for two VLAN. Yes, bro.
You use analog ports.
What?
Using analog.
Okay. So traffic type voice VLAN means voice traffic, voice over IP. With the help of IP, we are talking. Use case. Then management VLAN for management purpose, for management people. Server VLAN for servers. So if you have lots of server in one, at one floor or in one building, so you will create server VLAN. Guest VLAN, let's say you want to give Wi-Fi access to your guest, right? So you need to create guest VLAN, and in that VLAN you are going to map guest SSID, right, for wireless network. Storage VLAN, IoT VLAN. See, if I have some IoT devices, so I will put them in different VLAN. So see how I am categorizing the traffic. For each type of traffic, like server traffic, guest traffic, right? Storage traffic, IoT device, IoT traffic, voice traffic, data traffic. For each type of traffic, we have different type of VLAN. For HR VLAN, finance VLAN, development VLAN, and after that VLAN configuration. So this is how we are creating VLAN. Okay, so let me do one thing. Let me design one lab of VLAN. Now guys, till then tell me one thing. If I have one switch here which is connected with if both two ports are in different VLAN, these are in VLAN 10 and these are in VLAN 20, then can you tell me packet flow? Can you tell me packet flow on switch? PC2, MAC address 0A, IP address 10.1.1.1. MAC address 0B, IP address 10.1.1.2, 0/0 and 0/1, 0/3, 0/4. Done. These two are in VLAN 10 and these two are in VLAN 20. Now tell me, switch is going to maintain how many MAC address table? 2 MAC address table, right? One for VLAN 10 and one for VLAN 20. Let's say this is for VLAN 10. This is for VLAN 20. Now when PC1 will ping to PC2, how switch is going to process the packet? Tell me. When switch will receive, first switch will receive which message? Let's say these two devices are communicating for first time. First it will receive R packet, right? So with the help of R packet, it will learn what? MAC address. And in the previous class, switch was learning MAC address on interface, but today switch is going to learn MAC address in VLAN also, right? So there will be VLAN information first. VLAN 10 means this port is part of VLAN 10, where it is learning source MAC address, right? So first thing in the entry will be VLAN ID. So I am receiving a traffic on an interface which is part of VLAN 10. Then what is the MAC address? 0A, and which interface? 0/0. Then it will check destination. So destination is broadcast. Now I will forward traffic to those ports, from those ports only which are member of same VLAN. So we'll switch forward that broadcast message to REST PC, guys, to PC 3 or 4.
Sir,
Yeah.
so but you said that first time the PC will learn the VLAN ID, VLAN ID as well.
PC.
So how it knows that in my VLAN 0, 1 port
No, PC will not get to know my VLAN. Switch will maintain entry. Switch don't know I am in which VLAN. See, for that I have a separate server. That is automatic VLAN. Like if you want to put PC1 in VLAN 10 only. Otherwise, in this scenario, PC don't know I am in which VLAN. PC know only this is my IP address, this is my submit mask. So whenever you will send traffic to any IP address, it will compare that destination belongs to my network or not. If destination belongs to my network, then it will directly generate ARP. If node belongs to my network, then it will check default gateway, but default gateway is not there, so it will discard it. PC don't know MAC address now. Sorry, VLAN information now. PC don't know what VLAN information.
No, sir, not PC, switch. Like how switch will know that my
Because you have already configured now this port, switch port access VLAN 10. Once you will run command switch port access VLAN 10, switch is going to maintain VLAN database. In the VLAN database, it will make one entry that okay, VLAN 10 interface is. No, it is not learning by ARP. It will only check this thing that okay, my receiving interface is VLAN 10. That means I will forward it to those ports which are member of same VLAN, right? So it will check their MAC address table, this MAC address table, not entire MAC address table. So guys, after the communication inside the MAC address table of switch, there will be two entry for VLAN 10, 0 B interface 0/1. For VLAN 20, let's say 0 C on VLAN 20, 0 C 0/0. (0/1). And guys, switch will have one combo MAC address table as well, combination of both. But when switch will receive traffic on these two interfaces 0/0 and 0/1, it will check this MAC address table. It will check this MAC address table. But when switch will receive traffic on these port, it will check this MAC address table to forward frame. So while troubleshooting, if VLAN 10 users are not able to communicate, you are going to check this VLAN. See this MAC address table, not this MAC address table. So is it clear, guys, the difference in MAC address table of switch to all, and how VLAN means switch is going to process packet in VLAN. Now what I can do, I can create one lab. Let's suppose I'm going to implement one network again in building where I have 5 department or 3 department, let's say. So which type of devices I need? See, my requirement is all end devices should be able to access internet, as well as all devices should able to access network resources. Network resources means if there is DHCP server, so all devices should be able to get IP address from DHCP server. If there is DNS server, then all machines should be able to resolve IP address. If there is HTTP server, that should be accessible from all client machine. This is the requirement. Tell me how many devices are required and which type of devices are required. My requirement is I want to implement a network in a building where I have 3 departments, and let's suppose I have 300 clients. How many switches required, how many routers required, tell me everything. Which type of cable required and how many cables required. Three switch. Here, we can run almost all command. All commands are exactly like real router. Same command you are going to use on real devices as well, right? So if you are performing lab in EVE-NG, that means guys you are configuring devices in rack directly. Switch 1, switch 2, switch 3. Now guys, let's suppose your main subnet is, let me give you a subnet. Your subnet is 192.168.0.0 slash, let's say 16. Please divide it into 3 parts and tell me the network ID of each. Tell me guys, because I am going to segment the network. So first step is subnetting, because I am connecting devices. Right now I am using 3 switch and few computers. Now I can use one distribution layer switch. 4. Why I am using distribution layer switch? For distributing and aggregating the traffic, so that distribution layer will distribute the traffic between all access layer switches. In one scenario, we will connect one router, one switch to router as well directly, because that is also one scenario and most of the time we are using that also. So we'll see that scenario as well. Now what will be subnet for this department? Subnet for department 1. Guys, tell me subnet for department 1. You already know subnetting. Otherwise, I will use /24. So let's say here network is 192.168.1.0/24. Here network is 2.0/24. Not like this. For VLAN 10, see I have 3 departments, so I am going to use 3 VLAN. Let's say VLAN number 5, then VLAN 6, one 92.168.2.0/24, VLAN 7. You can use any VLAN, right? 192.168.3.0/24. So for 3 department, I have defined the network, right? Here guys, I have member in VLAN 10 and 20. This port is part of VLAN 10 and this port is part of VLAN 20. First question is, switch 1 is going to maintain how many MAC address? how many it is going to maintain, how many MAC address table. Any VLAN, let's say VLAN 10. And like this, we have, some user in all VLAN on all switches. Doesn't matter. Let's say VLAN 20, and in which VLAN you want to put PC8. Let's say VLAN 30, 10, 30. Now tell me, switch is going to learn MAC address of how many PCs, guys? How many MAC, total number of MAC address switch one will learn? Except default gateway. Two only. But now you can say like this, I have multiple user, because guys, in each department I have 100 number of users, or let's suppose 200 number of users. So you will have lots of MAC addresses. And good thing over here is as I told you, that I can use switch as a router as well. And when I am using switch as a router, means to perform routing as well, then we called it layer 3 switch. So this is, guys, layer 3 switch. Layer 3 switch. And layer 3 is responsible for routing, as well as this switch can perform routing between different VLAN. Like here I have 3 different subnet. So this device can make communication between each other. Why these means user from this network cannot communicate with this network? Because destination belongs to different network, so I will check default gateway. If default gateway is there, then only I can forward traffic, because destination MAC is unknown. If destination belongs to different network, then it cannot find destination MAC. So it cannot communicate. So if I will configure default gateway on core layer switch, guys, then all VLAN can communicate with each other. Then all VLAN can communicate with each other, because see, this device is acting as router now. It will maintain routing table. There will be 3 entry, right? And the IP address which is running on the core layer switch, I will define that IP as a gateway. So they can ping or not? Yes. So now let me do one thing. Let me configure these devices. So go to switch 1, config T, and say host name switch 1. Then guys, interface fast Ethernet E0/0, Ethernet 0/ not fast Ethernet, Ethernet 0/0. And I'm going to put this port in which VLAN? So I will run command switch port access VLAN 10. So you can see, when I am putting one interface in VLAN, and if that VLAN is not exist on switch, then switch automatically creating that VLAN. So what it's saying, access VLAN does not exist, creating VLAN 10. Do so VLAN brief. You can see this switch has already created VLAN. And guys, let's say VLAN 10 or VLAN 5 is my what we say HR VLAN, and IT VLAN, and let's say this is my admin VLAN. So I need to configure name as well, right? So let me configure name of VLAN, say VLAN 5 and name. This is how we create VLAN, and then we'll define name. Guys, if you will not exit from here, then you can see do so VLAN brief. Till now switch have not configured the VLAN, right? You have run the command VLAN 5, but until and unless you will not exit from here, it will not create VLAN. So if I will run command exit, now it will create VLAN. You can see VLAN 5. So again I am saying VLAN 5 and name HR. Exit. Interface E0/1. Switch port access VLAN. Which VLAN? 20. Right, again it is creating VLAN 20. Now VLAN not 26, no VLAN 20. Interface E0/1. Switch port access VLAN 6. VLAN 6 and name IT. Do so VLAN brief. VLAN 5. I don't have any port in VLAN 5, so I need to replace this port 0/0. Interface E0/0. Switch port access VLAN 5. Now so VLAN brief. VLAN brief. VLAN 5 I have E0/0. In IT I have E0/1. Like this you can have all three VLAN on single switch and you will have multiple ports. Done. Now let me configure switch 2. On switch 2, guys, I need to create which VLAN? VLAN 30 and VLAN 10. So let me say VLAN 30. Name VLAN 30 is admin VLAN, so let me name it admin and switch. That's it. Then interface. Oh my god, not VLAN 30, VLAN 7. VLAN 7 name admin. Interface E0/0. Switch port access VLAN 7. Let me rename it. This is your VLAN number 5. This is your VLAN number 6. Seven, 5, 7. Done. So on switch 2, done. Then I need to create one more VLAN, that is VLAN 5, and name of VLAN 5 is HR. Exit. Interface E0/1. Switch port access VLAN. Done. So VLAN brief. I have HR VLAN and admin VLAN. I have one user in HR VLAN, one user in admin VLAN. In the same way on switch number 3, config T, VLAN 7, name admin. VLAN 6, name IT. Interface E0/0. Switch port access VLAN 7. 0/1. Switch port access VLAN 6. So VLAN brief. Now guys, tell me, PC4 can communicate with which PC? Can PC4 communicate with PC5?
PC7.
Okay, 4 and 5 can communicate? No. Why? Because when PC4 will generate ARP request, it will forward to this switch, and switch will forward that broadcast message in VLAN 5 only. So switch will check MAC address like this. You know, switch number 1 is going to check MAC address like this. So MAC address table for VLAN 5. It will not check complete MAC address. Now guys, I need to configure IP on machines. So I have two options. First is manual, second is DHCP. So for now, let me configure manually. Here I am going to define one IP address. So what will be the first IP address for PC4? PC4 IP address. PC4 is in VLAN 5. VLAN 5 is HR VLAN. Subnet is 192.168.1.0/24. So IP address 192.168.1.1. Maybe I will configure last IP address as a default gateway IP address. Then subnet mask 255.255.255.0. So it is checking duplicate, but it is unique IP address. You can see it have assigned it to their interface. Then PC5, what will be IP address for PC5? PC5 is, yes, 192.168.2.1. Again, it's checking for duplicacy. PC6, PC6 IP address 3.1. But in real time, you will have how many devices? 300 devices or 600 devices. So you will configure DHCP IP 1.2. Eight. PC9. PC9. Now go to PC1 and tell me PC1 can ping to which PC? PC4.
PC7.
Can I ping to PC5? PC5 IP address is? Let me write the IP address, it will be easy. 192.168.1.1. Correct? 2.1. 3.1. PC7. 4.1. 2.2. PC7. PC9. Yes, let me take you to PC4 now. Ping 192.168.2.1. See, ping is not working, right? And check the MAC address table of switch. So MAC address table. See guys, MAC address table of switch 1. These are in VLAN 1. This user is in VLAN 6. This user is in VLAN 5. But if you will check MAC address table like this, so MAC address VLAN 5. See how fair it is, right? So checking this MAC address table and checking this MAC address table. And now you know the another benefit. Now you can change the MAC aging time for your critical data. Let's say department 1 is main department, critical data are there, critical users are there. So I will increase the MAC aging time for that department, for that MAC address table. MAC address table aging time. We had seen this command, right guys? Now I can say VLAN. Now I can say VLAN 10. So it will set this MAC aging time for VLAN 10 only. So see, now I have control on MAC address table as well if I have multiple VLANs. So MAC address table aging time, you can see for VLAN 10 MAC aging time is 5000. For rest VLAN 300 second global aging time. So my VLAN 5 is, or my VLAN 6 is critical user. So I can say VLAN MAC address table aging time for VLAN 500 or 5000 for VLAN 5, like this. Okay, so PC4 is not able to ping PC5. Can PC4 ping to PC6? PC6? No. PC7?
Yes.
Why ping is not working? Because this port by default switch port is member of which VLAN? VLAN 1. When I am pinging to PC number 7, so this port is part of which VLAN? VLAN 10. So switch will check MAC address table of VLAN 10 only. This port is not part of that VLAN. So even if it will generate broadcast, it will flood the traffic, means it will forward traffic to all ports, then also switch is not going to forward it from this port because this is different VLAN. So what I can do, I can configure this port as VLAN 20. I can put this port in VLAN 20, but can VLAN 20 user, what for VLAN 20 user? Will this port carry VLAN 20 information then? No. So this is the issue. By default, this port is member of VLAN 1. I can put this port in VLAN 10, then it will carry traffic of VLAN 10 only. And if I will put it in VLAN 20, then it will carry traffic of VLAN 20 only. So how PC4 and PC7 will communicate with each other? Or if I will put it in 10, then maybe PC4 and PC7 can communicate. But then how PC5 will communicate with PC9? So guys, I can configure this port for all VLAN. I can configure this port for all VLAN. That is trunk. So you can configure this port as a trunk port. So these are, port which is member of single VLAN is known as access port. There are two types of actually switch port. Switch port means port of switch. Port of switch. So there are two types of port switch. One is access and another one is trunk. Access port is the port which carry traffic of single VLAN, means like this. You can see this port is member of VLAN 10. So it will carry only VLAN 10 information. And other type of port is trunk port, which will carry traffic of all VLAN. So your switch port will be either access port or trunk port. So these two ports which are connected with end devices will be always configured as access port, but the port which is connected with another switch will be configured as trunk. So I will configure this interface as trunk interface. So go to switch number 1. I have already console. Where? PC7 1.2. So on switch number 1, guys, go to interface E0/2 and say switch port mode, and see you have two options. Either you can configure access or trunk. So by default it is dynamic, desirable, dynamic auto by default, right? We will talk about these port later. For now, just think like there are only two types of switch port, access and trunk. Don't worry about rest. So this is protocol. So now I am going to configure this mode as trunk mode. By default it is access port. For which VLAN? For VLAN 1. Correct, guys? Done. So what it's saying, first of all you have to configure encapsulation protocol. The reason, what will happen, see, if you have configured this port as a trunk port, then you need to configure this port also as a trunk port, because on this switch also this port is going to carry traffic of multiple VLAN. So this port should be also trunk port. Now question is, when switch number 1 will forward traffic of VLAN 10 to distribution switch, let's say ICMP data, right? And it have received it on 0/0 port. This port is trunk port, means member of VLAN 10 also, so it will forward this data from this port also. How this switch will come to know that this data is belongs to VLAN 10? Correct or no? Not. How this switch will get to know? Because on this switch, let's suppose there are multiple ports. Some ports are in VLAN 10, some ports are trunk port. How this switch will forward it? It have to first identify that this traffic belongs to which VLAN. So before sending to distribution layer switch, this switch have to add some extra information with this data, right? And that is called tagging. That is called tagging. So whenever a switch will forward data on trunk link, it will add a small header. That header is going to carry VLAN ID. So here it will put VLAN ID, that this data is part of VLAN 10. Okay. So if it is going to add to header extra information, then definitely we need a protocol over here. So let me configure one protocol here, guys. We have two types of protocol. One is .1q, another one is ISL. That is encapsulation protocol. Who is going to encapsulate the data? Encapsulate means adding extra information. This time extra information is tag number. So first say switch port trunk encapsulation protocol and see .1q and ISL, or it can negotiate. So here I am saying .1q and then say switch port mode trunk. Now this port is trunk port. You can verify, so interface trunk. Right? So E0/2 mode, encapsulation protocol, status and native VLAN. Don't worry about the native VLAN also. We will see native VLAN later. So guys, how many VLAN are allowed on this link? All VLAN 124094. All VLANs are allowed on this link. And how many VLANs are exist in database? VLAN 1, 5, 6, 10. 1, 5, 6, 10 for VLAN. You cannot delete VLAN 1. And this is about a spanning tree, we will see later. Right? Now in the same way on switch number 2 also I need to configure E0/0 as trunk. So let me access and let me say enable config T interface E0/2 switch port trunk encapsulation.1q switch port mode trunk. Nowadays we are using .1q, right? Nowadays no one is using ISL, but also we'll see the difference between ISL and .1q later. I've configured the trunk link. Now can PC4 ping to PC7? Now what is the issue?
Switch 2 also name.
Distribution layer switch. Let me access distribution layer switch. See guys, enable and so interface trunk. It have already negotiated the trunk. Protocol is running, right? By default, encapsulation protocol is negotiation. So if you are going to configure it on switch 1, then automatically distribution layer switch is going to negotiate it. So these port are trunk port. Now how you will troubleshoot if PC4 and PC7 are not able to ping? Now tell me guys, how you are going to troubleshoot it? And just give me 1 minute. Yes guys, first of all you will check ARP table of PC, that PC is able to learn MAC address of PC7 or not, correct? Right? So let me take you to PC4. And I can say ARP, only ARP. ARP table is empty. Now what you will do? You will access switch 1 and you will check MAC address table that this switch is able to learn MAC address of switch 4 or not. So switch PC4 is connected with switch number 1 E0/0 and E0/0 is part of VLAN 5. So MAC address table VLAN 5. Yes, this switch is able to learn MAC address of PC4. Now let me access core layer switch. Let me check core layer, distribution layer switch. Distribution layer switch is able to learn it or not. So MAC address table VLAN 5. No, distribution layer switch is not able to learn MAC address. So ports are up. Even you can run command show interface status. Important command for real time. So it will show you trunk port and access port. These two ports are trunk port. These two ports are access port. And status is connected. All ports are connected. Working on full duplex. Configure mode is auto. This aim is auto. Type is RJ45. Speed is again auto. It is going to negotiate from the neighbor device. So why this switch is not able to learn MAC address? So see guys, when PC 4 will ping to this IP address 192.168.1.1 2.2 or 1.2? 1.2 na? 1.2. But still ping is not working. Now let me check distribution layer switch is learning MAC address or not. So MAC address table for VLAN 5. So MAC address table. This switch is learning any MAC address on 0/0. Yes. Is it a MAC address of PC4? So all no. This is not MAC address of PC. Still distribution layer switch is not able to learn. Now you need to troubleshoot it. And one time let me check IP address on PC7 as well. So on PC7 also you can see IP address is correct. Now I will access layer switch 1 and I will check. So interface trunk. So E0/2 is configured as trunk. Okay, everything is correct. All VLANs are allowed over here. Now show VLAN brief, VLAN status. So VLAN status is active. E0/0 port is there in VLAN 5. Now let me say check switch 2. So VLAN brief. VLAN 5 HR VLAN and we have E0/1. See guys, correct port? Correct port. So interface trunk. Status is trunking, all VLANs are allowed. You know what is the issue? See distribution layer switch. So VLAN brief. Do I have VLAN 5, 6 and 7?
No.
No. Right? So guys, that VLAN should be in VLAN database. Then only switch will process data for that VLAN. If VLAN not exist in the VLAN database, if it is receiving a traffic, let's say of VLAN 10 and VLAN 10 is not in database, then switch is not going to process it. That VLAN should be there in the database. So here I need to create 3 VLAN actually. VLAN 5, because see now when PC4 will send ARP message, let's say, so this switch is going to learn MAC address of PC4 on this port. This port is configured as trunk. So this switch should learn MAC address of PC4 in which MAC address table? VLAN 5, correct? And VLAN 5 is not exist in the database. So here I need to create. Yeah.
Sir, by default distribution layer all ports are in VLAN 1, right?
Yes. But when you have configured the trunk port, that means now ports are member of all VLAN. This is not by default, na. I have configured the trunk na this side on access layer switches. I have configure encapsulation protocol .1q for trunking, and here encapsulation protocol is negotiation. So it will negotiate and it will also set .1q here. Then you have configured this port as trunk, and here port is configured as negotiation for trunk. So it will negotiate the trunk and it will also set their port as trunk. So these ports are trunk port by default now.
So 40 all ports are in all VLANs are allowed, right?
Yes. VLAN
Sir,
6, yeah.
but VLAN 10 also is there in the communication part. Why you have the database separately one
No, I can delete VLAN 10. See guys. Yeah, yeah.
First of all, yeah, in VLAN 10 you have to mention, right? This is the communication part of the in the
Where is VLAN 10? No, then I have changed the VLAN ID. Na, I told you na, you can give any number. So let me give 567.
Previously you have mentioned VLAN 10, right? That is the confusion is there. You have mentioned multiple types of VLAN
Bro,
VLAN 10.
okay. So earlier this was in VLAN 10. Yes, really, this is bit confusing. And extremely sorry, brother. I'm saying VLAN 10, 10, na? VLAN 10, VLAN 20. I am still, assuming this PC is in VLAN 10 only. This is the issue. But 5, 6, and 7. So I have see VLAN 5 here, 6 here, and I need to create one more VLAN, that is VLAN 7. Now can PC 4 ping?
Yes.
Right now, yes, it can ping. And now CPC 4 done. Ping is working, and on distribution layer switch you can check the MAC address table. MAC address table for VLAN 5. So you can see it is learning MAC address. How many users are there in VLAN 5? 3 users, 2 users, 2 users. How many users are in VLAN 6? In 7, 2. And now these all can communicate with same VLAN users. Now if you want to make communication possible between these all VLAN, simply you can configure default route. So go to distribution layer switch 1, and here I can create one virtual interface for each VLAN, like interface VLAN 6. On this interface I am going to say no cert and IP address 192.168.2.254. Last IP address from this subnet, VLAN 10 subnet, right? Then interface VLAN 5 IP address 192.168.1.254 and say no shutdown. Interface VLAN 7 say IP address 192.168.3.254.255.255.255.0 and no set. Now you can see this router is going to maintain routing table, so IP route. See this switch, by the way, this is switch layer 3 switch, but it is acting as router. Done. Now you can verify yeah. This device is acting as both router and switch. See, it is connecting these devices at layer 2. So this is function of switch, connecting multiple networking devices together, and it is also connecting multiple network together, so it is behaving like router as well. So
These devices have created the interfaces, right?
correct. I have created one interface for VLAN 5, one for VLAN 6, one for VLAN 7. And sorry, brother, earlier I was saying VLAN 10, 20, 30. It's a habit. Is it clear now? 100%?
One time you get to go for video privacy.
But if any devices are not able to communicate, then I'm expecting that you can troubleshoot it. You can check MAC addresses table, RP, this, and you can troubleshoot it finally. Now, guys, see in the switching, this network is weak because we don't have redundancy at distribution layer. If this switch will goes down, or let's suppose this cable will goes down, then VLAN 5 and VLAN 6 users are down in department 1. if this link will goes down, then VLAN, all VLAN 5 users, all VLAN 6 users, all VLAN 7 users will goes down. In the other building, network is still up, but in this building or if in this department, you can say this is a building also, you can say this is a department also, right? So in this department, all VLAN will goes down. So we don't have redundancy. So what I will do, I will add one more distribution layer switch here, right? D switch 2. And again, I will connect all access layer switches to this distribution layer switch as well, right? Yeah, I can configure active passive also. I can achieve load balancing also. Like let's say both distribution layer switches connected with router. So now I can configure this scenario in such a way so that this switch will forward traffic of VLAN 5 and 6, 1 or 6, or this will send let's say 5 or 7. So it is what load balancing. I can configure so that switch 1 is going to forward VLAN 5 and 6 traffic, and this one is going to provide 6 as well as 7 traffic. Like this, if I have multiple departments, so I can configure 7 and 8 for traffic of VLAN 7 and 8 via distribution layer, right? And this auto is connected with internet. So now you can see I am performing load balancing between 300 users or 600 users, between 600 clients. I have, let's say I have equal number of clients in each department. So I am doing 50-50 load balancing, 50% from this side and 50% from this side. But let's say if I have more user in VLAN 10, then you cannot say it is a equal cost load balancing, right? Equal load balancing. Ratio is not same then. There are multiple types of load balancing as well, guys. So what we will do, we will add this switch. And now guys, try to understand the issue in this scenario. What is the issue, right? Tomorrow we will discuss about the issue in this scenario. Okay. And we are going to fix it with the help of again protocol. So that protocol will be next topic. So today we understood VLAN. Is it clear to all? Clear and crystal? Real-time use, configuration, why we need it, what is the benefit of segmentation? All clear? Yeah. Oh my god. Yeah, go through the video and must configure by yourself once. Packet tracer is also fine. In packet tracer, just drag and drop 5 to 6 switches, create 20 number of VLAN, right? And manage it, configure the link between switches as trunk. And day by day, I will tell you what features you are going to implement over here to improve it. This is basic communication, right? Now we to learn how to improve this. So day by day we are going to configure protocols on these devices. Any question, guys? Anybody?
Sir,
Hmm.
what are main difference manageable
Manageable switch, you cannot configure unmanageable switch. Manageable switch means you can manage it. You can configure it. Like you can see, these are what manageable switch. In unmanageable switch, there will be some basic configuration in the operating system, and you have to manage with that configuration only. Right now, like you can see on the switches, there are some basic configuration, right? Devices can communicate with each other, but this is not sufficient for real time. Now we are going to implement lots of protocol here. I'm going to use it according to my requirement. Now I'm creating VLAN according to my requirement. But if you have unmanageable switch, then you cannot manage it, you cannot use it according to your requirement. That is fixed. Like hub, you can say that is not hub, means it will not perform broadcast every time. That is only difference from hub to unmanageable switch, right? So
you have created a one last
No, I have created one virtual interface. Like, see, line VTY interface is here on the router. Those are what virtual interface. So like that, I have created one virtual interface here for VLAN 5, one for VLAN 6, one for VLAN 7. Anything else? Clear? No. See, if I have created one virtual interface on the device, so my device is going to generate one MAC address for that virtual interface. So each switch has one base MAC address, right? You know, each switch has one base MAC address. So with the help of that base MAC address, it will create virtual MAC address, logical MAC address. We will see how it will create virtual MAC address on the switch. Don't worry. Right, so you have defined the IP address, it will automatically create MAC address. So now port have source destination, it can communicate. Got it? So hope you guys have understood the real-time use of VLAN, virtual local area network. Tomorrow is the main day of this course. Tomorrow we are going to start routing, right? Hope I am expecting now your basics are very clear. So from tomorrow you can say we are starting NRC course, right? CCNP NRC. Whatever topics I have in CCNP NRC will cover everything. And guys, except these topic which we have discussed, right, like basic OSI model, IPv4 subnetting, encapsulation, decapsulation, packet flow, ARP, ICMP, application layer protocol, this was part of CCNA, basic of CCNA. Now in CCNA you have routing. So I'm going to combine routing of CCNA into CCNP routing. Like OSPF. OSPF is in both syllabus, CCNA also and in CCNP also. So when I will start OSPF, I will start from 0. I will start from 0 and will go till CCNP level directly. That means I'm covering CCNA as well as CCNP at the same time. Done.
Yes, sir.
So class is going to be really interesting. In the routing, we will have around 20 classes. So see in upcoming 20 classes what we are going to learn.
So DMVC will be covered?
Yeah, 100%. Why not? DM VPN over IPsec also covered.